Good morning, everyone. This is Cassie Stumo. I am the marketing specialist here at EAC. We will begin today's session with an introduction of EAC. Then Dmitry Slavkovich, PTC's technical specialist, will be diving into how you can implement IoT into your business with PTC's ThingWorx technology. Everyone should receive a recording of this session pending any technical difficulties. So please feel free to drop questions in the chat and we'll answer them after the presentation. All right, if you want to go to the next slide, Dimitri, thank you. Okay, so for those of you who do not know who we are, I'll start off with a quick introduction to EAC. Our mission is to transform the way companies design, manufacture, connect to, and service their products. We are not only a value-added reseller for PTC, but we are the #1 solutions provider for PTC in the country, something EAC is very proud of. If you want to go to the next slide. We have experts in 22 areas of product development and are located all over the US, with our headquarters in Burnsville, Minnesota. We offer customers everything they need for product development, such as service lifecycle management software, which helps you create and manage service documentation, product management software like Windchill, ThingWorx, Navigate, and our customizable EAC productivity apps, which helps you manage internal product data. We implement the Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. You can, oh, perfect. We assist with design and engineering projects like FEA, simulation, reverse engineering, and proof of concepts for our customers. And we offer webinars and PTC certified training courses for continuous learning. We're also a commercial reseller for Formlabs. We offer the Form 2 printer. It's an SLA desktop 3D printer that delivers high resolution parts and prototypes for as low as $3,500. So please keep us in mind. We really have a variety of tools to help your organization save time and money throughout the product development process. And that's what our job is to help you excel at what you already know how to do best. So I'll go ahead and hand it over to Dimitri, who can talk to us about the foundation of ThingWorx technology.
Awesome. So ThingWorx has been used by hundreds of companies worldwide to accelerate their time to value with our ThingWorx platform, which includes industrial connectivity, foundation, as well as analytics. Our pre-built ThingWorx apps that include manufacturing apps, Navigate, software content management, as well as Asset Advisor for service. And then our supporting ecosystem, which is comprised of a large number of IoT partners, customer success. We have an IoT university, as well as our PTC marketplace. And so we'll just go through some of the capabilities ThingWorx provides. And so we drive industrial innovation through 5 phases. So ThingWorx enables developers and solution builders to incorporate and aggregate data from anywhere. We can contextualize the data in a model-based environment, so structuring in a way that makes sense. We can gain valuable insight through analytics, simulation, as well as prediction, and then drive action and results in physical and digital systems. So by automating processes that connect business systems data, products, and physical operations. And so this is all on a secure and scalable architecture, and ThingWorx helps enterprises make money, save money, and then reduce risk all from one integrated platform. And so the first step in any application is to connect to sources of data. And so ThingWorx makes this easy regardless of where that data is coming from. Anything from remote devices to enterprise business systems. And so connections can be made in several ways. ThingWorx Always On connectivity protocol provides secure, IT-friendly bidirectional connectivity, which includes file transfers and remote device access, as well as edge intelligence, which includes calculations and data filtering prior to sending that data over the network. And then because of ThingWorx Dynamic REST API, any device, system, or language that's capable of REST HTTP requests can communicate with the platform. ThingWorx is also extensible to support proprietary protocols. This is made simple using our protocol adapter toolkit. It also supports emerging standards such as MQTT and CoAP, and has native cloud support for Amazon Web Service, Microsoft Azure, GE Predix, Exida, and more. We can also easily connect and communicate with thousands of industrial devices and systems using Kepware, which is also known as ThingWorx Industrial Connectivity. So it has protocol drivers for over 150 different PLCs and controllers, as well as OPC UA, BACnet, and MQTT capability, just to mention a few. ThingWorx also makes it possible to include digital content from engineering systems, such as Windchill PLM. And with its open connectivity model, ThingWorx does make it possible to connect with business systems such as SAP or Salesforce. And so all this data must be contextualized to be able to make it useful. However, different sources of data might not speak the same language or use the same formats. So in order to create the proper context to consume the data, we put a semantic model in place that the consumers of the data understand without being taught. So this model-based development and ThingWorx Thing Model specifically provides many advantages. So it defines a meta model that allows consumers of the data to understand it in common everyday terms. It eliminates the need for developers having to build and maintain a database schema or write low-level code for common tasks such as data ingestion, translation, and triggering business logic. And then it also makes team development easier and more consistent because it enables drag and drop mashup development. And so the model things are the basic building blocks of a ThingWorx application. Things are defined by properties, services, events, and subscriptions. And so I'll go through each one of these. So properties include the kind of data that describes a thing or that can be provided by that thing. So properties can be static, such as serial number, or dynamic, such as temperature. Services are functions that a thing can perform. So they could be as simple as an SQL query to a database, or they might execute some JavaScript code to be able to perform an action. An event is something that happens to a thing. So these are built-in events such as when a property value changes, an alert occurs, or a timer goes off. And so you can also define your own custom events. And then these events are subscribed by other entities in the system. So subscription is an action that executes when an event occurs. And so as the thing model is built and evolves, it automatically generates a REST API that these other systems can use. And so what's new in ThingWorx? I'll just go through this pretty quickly. So we have our next generation composer, enhanced connectivity. So other than Kepware, we do offer a few ways that you can connect up to your devices or business systems. High scale architecture, single sign-on capability. So you could use your enterprise sign-in to be able to sign in. And then analytics integration, as well as software content management and advanced workflow and business system integration. And so now I'll go ahead and go through our demo. So first thing we'll do is I'll run through an application that we created. We did invent the company. And then after that, I'll show you guys how you would go about creating something like that. And then we'll finish off with one final slide. So if everybody is ready, I will go ahead. And so ThingWorx really is PTC's industrial innovation platform that enables the quick and easy creation of industrial IoT applications as well as AR experiences. We do support a variety of deployment options, as I mentioned in the slides, and those include, third-party clouds such as Amazon, Azure, or Google. But you could also host the solution with PTC Cloud Services or host the solution yourself. But this application was created using our standard tool set. So everything you'll see in this demo is something you could do yourself with only a little bit of training. And then after that finished application, like I said, we will show the back-end modeling tools and use our composer environment to build an example mashup for you. And so this will really demonstrate the tools used to build such an application and then how the model enables fast development of apps. So like I mentioned, BeanPro is a company that we invented. They buy raw coffee beans from farmers, roast the beans, and then sell these beans to high-end coffee shop operators. And so this application really allows roasting machine operators to see the status of roasters and to collaborate and share their information more easily. as well as for operations managers to monitor customer inventory status and coordinate the replenishment of product to coffee shops. And so I'll go through each one of these tabs. We'll start off with our roasters tab. And so this is a default mashup for monitoring roasting operations nationwide. You can see on the left here, we do have all these regions as well as specific roasters within those regions. So I can go ahead and select on one of these. And so this will give us now a regional summary of our roasting operations. We can still see locations on the map, but we're getting a little bit more detail on these individual roasters. But I can dive in even further and select on one of these. Awesome. And so here we'll get a detailed view of the selected roaster. We have real-time roaster data updating on the graphical representation of the roaster. We're also pulling in weather data, and that's coming from an external service because local temperature and humidity conditions are important in the roasting process. And this can all allow us to automatically respond to conditions using not only data from a device, but data from other systems to be able to react intelligently and proactively to these changing conditions. So now here in our info icon, we can see all the data easily collected in a grid view. So all the roaster properties that we find important in this roasting process. And then here in our humidity icon, this is an example of event management. So here, this top slider right here is our max threshold. Our bottom right here is humidity. And so each time the value changes, a subscription runs to see if this value is now over the threshold. If not, nothing happens. But if so, the subscription will catch this and react by automatically initiating a voice call. So here you can put in a phone number, and then when that goes over the threshold, Twilio will go ahead and execute a phone call. You could do this also, you could send out messages, emails, really however you would like to alert that technician, you do have the full capability of doing so. But I would like to mention that in a real scenario, we would set that threshold, but the humidity value would come from a sensor. And so now we can take a look at our operations view. And this is for our area sales manager to get insight into product consumption and to be able to manage these replenishment orders, ensuring coffee shop customers always have that coffee bean inventory. And so this screen is an example of that. We're using data from 5 different sources to be able to create this application. So we have customer location, which is coming from a CRM system. Beginning inventory, which is based on the last order and is from our order management system. Usage data, which is being reported to us from these connected coffee machines at customer stores. And then we can see where all the delivery trucks are in our fleet because they're submitting their location, as well as how much product is on each one of those trucks. And so I can go ahead here, and what I'll do is I'll just use our filter to see, maybe one of these stores has less than 20% of city roast. And so here we can narrow it down to these 2 stores. So I'll go ahead and place an order manually. So here we can see, previous order, their current level of roast. And so clearly, they need some more roast. And then we have all the trucks, how far away are they from the store? How much roast do they have? And so clearly, none of the trucks at the current moment would be able to deliver French roast. So maybe we can at least deliver some city roast. And so normally we'd pick, the truck that's probably closest, but just because these do lack in inventory, I'll just go ahead and select truck 4, and we'll go ahead and send over about 400 of city roast. And so when I submit that, you'll get a little receipt kind of letting you know that order was just put through and the truck has arrived and delivered the inventory. And like I mentioned in this example, I did do all the searching and order placement manually via user interface, but in reality, we would automate this process instead. So we would enable the system to react automatically to the low inventory and then create these orders without any human intervention. And so here is just a dashboard. These are runtime capability for building personalized views from a library of predefined visual gadgets. So here is where, a specific role can come in and really create the dashboard that means the most to them. So I can go in here, we can add a gadget. And so depending on what region they're on, maybe what, roasters they are responsible for, they can select that and really set up the dashboard to be for them specifically. And we can also edit and delete gadgets as well. And then finally here, we have our collaborations tab. So this view showcases the forums and wiki widgets. ThingWorx offers dozens of visualization widgets with its Composer application, and our collaboration features are exposed to the model, really allowing not only users, but things, services, and systems to be able to collaborate on documentation and conversations. And so now that we kind of showed you guys an application, I'd like to go into the back end and show you the tools that we use to be able to create this. So this is our ThingWorx Composer. And like I said, it's the tool that we use to build, model and build these HTML5 applications. And so it's delivered via a web interface and can be used from anywhere as long as you have credentials. We also have a robust training curriculum, which teaches about all these modeling tools in detail. And so here on the left-hand side, we have the ability to create and manage various models and data storage entities, graphical items, as well as security for IoT applications. But what I'll do first is I'll go ahead and show you guys what one of these thing templates look like, one of these thing models. And so I'll find our coffee simulated truck template. And as you remember from our slides, when I went through the thing model, I discussed the properties, services, events, and subscriptions. So here I'll actually show you a thing model and show in a little bit more detail what these all look like. So as I mentioned, a property is a piece of data that's related to a thing. These properties can be static, such as serial number, or dynamic, such as temperature. And so in the top here are properties specific to that simulated truck template. In the bottom, we have a larger set of properties that are shared by all these delivery trucks. For services, like I said, functions that thing can perform, and it defines interaction with other elements and things in the system as well. So they are encapsulated pieces of business logic written in JavaScript. These services have defined inputs and outputs, which are also strongly typed. And since everything's strongly typed, it really enables us to do this codeless mashup. So creation by dragging and dropping properties of a certain type onto the inputs of services if those types match up. So I'll go down here and select the magnifying glass for Git history. And this will show an example of a script. So just ordinary JavaScript. So it's really easy to find support and code snippets via common mechanisms such as Stack Overflow or Google searches. But what this code is ultimately calling to is a service called query streams entries with data. And there's calling this service to get the result, which is just a table of data values between the start and end time. We have our events, which are triggered by defined conditions, but they're only notifications, so they really don't do anything. And then the subscriptions, these are the actions that should happen in the case of one of those events. So, it could be an action such as sending an email or even starting a workflow in another business system. And when I was showing you the Bean Pro example, an example of that was when that phone call was triggered if the humidity went over the threshold. But these are also encapsulated pieces of business logic written in JavaScript, but instead of running in response to a REST API call or a UI event like a button push, these subscriptions execute as a result of an event. So a good way I like to think of subscriptions is that they're simply event handlers. So after defining the properties, services, events, and subscriptions for a template, we can then begin to use that template and instantiate individual things and start collecting data. So now we can go ahead and actually create a mashup using that template. And so here, I'll just go over quickly the layout options. Responsive just means whether you want it to respond to the device that you're looking at on it. So whether you're looking on an iPad, your phone, or a desktop. Versus static would be if you're making it just for an iPhone or just for a desktop. So we'll go with the responsive layout and we'll get started. And so here on the left-hand side, you can see we do have all these widgets that are readily available. So yet another benefit of this platform approach. And so I'll go ahead and use this layout widget to set up how I want my mashup to look. So first, what I want to do is I'll have some space here. I'll put our Google map here where we can track our trucks. I'll do a grid up here so a table grid where you can track as well. And then down here, we'll have individual gauges. And so you'll see when we select a truck from the list or from the map, that these gauges will change depending on that truck that we choose. And so, like I mentioned, drag and drop. I'll easily go over and drop my Google map as well as my grid. I'll do the same for our gauges. And so now that our widgets are laid out, we need to really bring in our data via services and wire it up to these widgets. So here on the right, we can go ahead and add entity. And I'll go ahead and look for my simulated truck. And what we want is queries and query implementing things with data. And so services that you need to populate the initial view will usually be set to run when the mashup loads, but other services will execute later in response to UI events or on a timer, for instance. But we'll go ahead and load up the mashup. And so now we can see all the data related to the truck. So here, selected rows, I can select a specific property versus all data is dragging all of these properties. So I'll drag all data onto the grid. We'll bind that up. And then if you notice in the bottom, this will also show you when data or a specific property is bound to a widget. We'll do the same thing for our map. But the map only allows us to select properties that have a latitude, longitude, location type defined. So in our model, there's only one such property. It is called location. And so we'll just go and select that. And so in the bottom left here, you can see location field. I'll select location. And that's just so it knows that it is looking for that latitude, longitude, so it can locate the exact location of these trucks on the map. Now for the grid, it doesn't require this kind of configuration, but I can use its configuration options to set the order of the columns in the grid. I could also turn off unwanted columns or even apply state-based formatting, which causes those cell contents to render with different styles based on their values. But now that we have those set up, what I'll do is I'll just finally bind something with the gauges. So, what properties are of interest to us? We'll probably go with the current speed of a truck. And then why don't we go ahead and do trailer humidity? And so now that we have our gauges, our widgets set up, as well as the data bound, we can go ahead and save. And then we can view our mashup. And so obviously the gauges are idle since we have not selected anything from the map or the grid. But when I select a truck in the list, you can see that all the other widgets automatically update in response to that selection. But here you can see we built this mashup in just a few minutes while discussing the content or the concepts, really with the hope that you can see the potential of what can be built by a trained user.
All right, thank you, Dimitri, for that demo. I hope this presentation gives you an idea of how you can implement the industrial IoT into your business. If not, and you still have questions, please reach out.